Hey, got a physics exam coming up? Then you are in exactly the right place. In this explainer, we're going to really nail down two huge concepts that, trust me, will definitely be on your test: reflection and refraction. So, to get our brains warmed up, let's start with a few puzzles. You've probably seen this one a million times in class. Why is it that a perfectly straight pencil suddenly looks, well, bent or even broken the second you dip it in water? Okay, here's another one for you. We all know the moon isn't a star, right? It doesn't make its own light. So how on earth does it light up our night sky so brilliantly? And one last one. Think about it. How can you see stuff in your room, even in the shadowy corners where the sun's rays don't reach directly? By the time we're done here, you're going to know the answers to all three of these questions, no problem. So here's the game plan. We'll start with those puzzles, then cover the basic properties of light. After that, we'll dive deep into reflection, then refraction, and finally, we'll put them head to head to make sure it's all crystal clear for your exam. All right, first up, those everyday puzzles. I know they can seem a little like magic tricks, but I promise you they're all explained by a couple of fundamental rules about how light works. Okay, so before we can really solve those puzzles, we have to get back to basics. We need to talk about the fundamental rules of light. And yeah, these are definitely things you'll want to have locked in for your test. First things first, a number you absolutely have to memorize. Get your highlighters out for this one. In a vacuum, light zips along at an incredible 300,000 kilometers per second. That's not just fast, it's literally the speed limit for the entire universe. But here's the catch. That incredible speed isn't always the same. As you can see here, light actually slows down when it travels through different things, what we call media. It's at its peak speed in air, but then it takes a hit in water, and it's even slower in glass. Now, this change in speed, remember that, it is the key to understanding refraction, which we'll get to in a bit. Okay, so when a beam of light hits any object, one of three things is going to happen. It can pass right through it, that's transmission. It can get soaked up as heat, that's absorption, or it can bounce off, and that's called reflection. Let's talk about that one first. Which brings us to our first major topic, reflection. You know, reflection is the reason we can see, well, pretty much everything that doesn't glow on its own. From the phone in your hand to your own face in the mirror. All right, here it is, your core textbook-style definition. Reflection is simply the bouncing back of light from a smooth, shiny surface. Simple as that. You're going to want to have this one memorized for sure. And this is how it works in the real world. You've got light from a source, let's say the sun. It travels and hits an object, like this flower. Then that light bounces or reflects off the flower and straight into our eyes. And bam, that's how we see the flower. And just like that, we've solved one of our puzzles. Remember the moon? It doesn't make its own light at all. It's basically acting like a giant dusty mirror up in space. It looks so bright because it's just reflecting the sun's light right back at us. Okay, on to our next big concept, refraction. This is what happens when light doesn't bounce off something, but actually passes through it, from one type of material into another. Think light going from the air into a glass of water. And here's the next definition for your notes. Refraction is the change in direction of light when it enters from one medium to another. In other words, it's the bending of light. That happens right at the boundary where the two materials meet. Now, this diagram is super important. It shows the two rules you need to know. See that dotted line? That's called the normal, and it's just an imaginary line that's perpendicular to the surface. Okay, rule 1. When light enters a denser material, like going from air into glass, it slows down and bends towards the normal. Rule 2. When it leaves and enters a less dense material, it speeds up and bends away from the normal. Knowing which way it bends is a classic exam question, so pay close attention to this. This whole bending thing is summed up by two official laws of refraction, and yep, you guessed it, you should probably know these for the test. The first law is pretty straightforward. The incoming light ray, the bent ray, and that normal line we just talked about, they all lie on the same flat surface. The second law basically says that how much the light bends is all about how much it slows down or speeds up. The bigger the speed change, the bigger the bend. So with that, we can finally solve our very first puzzle. The pencil in the water. Why does it look bent? Well, the light that bounces off the part of the pencil that's underwater has to travel from the water, through the air, and then into your eyes. When that light crosses from water to air, it bends, it refracts. And that bend tricks our eyes into thinking the pencil is in a slightly different place than it really is. All right, time to bring it all home. A really common mistake on exams is getting reflection and refraction mixed up. So let's put them side by side and nail down the differences once and for all. Think of this table as your ultimate cheat sheet. What's the biggest difference? Reflection is about light bouncing off a surface, and it happens in just one medium. Refraction is about light bending as it crosses from one medium to another. Reflection lets us see things like the moon. Refraction is what causes cool illusions, like that bent pencil. When you boil it all down, it comes back to this one simple but really powerful idea. Light is a form of energy that lets us see everything around us. Whether it's bouncing or bending, it's the messenger that connects our eyes to the entire world. So there you have it. We've cracked our puzzles, and now you are totally armed with the science you need for your exam. But I've got one last question, and this one's for you. Now that you know how light bounces and bends, what other stuff can you explain? Like a mirage on a hot road, or why a fish in a pond always looks like it's closer to the surface than it really is? Think about it.